In this video, I will give you a quick overview of MATLAB Live Editor with a focus on running the MATLAB LiveScript. The MATLAB Live Editor was introduced in 2016 with slight variations across different versions. It provides an interactive environment where you can write and execute code, visualize results, and document your work all in one place. It is different from MATLAB scripts. MATLAB scripts follow a traditional linear workflow, where code is written and executed sequentially. It typically focuses solely on code execution without built-in support for rich text or visualizations. While efficient for executing predefined tasks, they may require separate documentation for explanations and visualizations. In contrast, MATLAB Live Editor provides an interactive environment where code, explanations, and visualizations can be seamlessly integrated. They support formatted text, equations, and various programming languages such as Markdown and HTML besides MATLAB code, so it facilitates comprehensive documentation and analysis. Also, they support real-time modifications, live execution, and some other interactive elements. In the following, we will explore code execution and some interactive features in MATLAB Live Editor. Let's start with a quick look of the MATLAB Live Editor interface. As a side note, I'll be demonstrating using MATLAB 2024A. The first step is to create or open a LiveScript. It is basically the same as what you do with MATLAB script. So from the same place, you can create a new LiveScript by clicking on blank LiveScript. Or you can open the created LiveScript by clicking on Open File. Here I would just right-clicking on the LiveScript in my current working folder and select Open. Once the LiveScript is created or opened, you will see the Live Editor toolbar appear here. For this script, you can see some blocks as well as explanatory text interspersed throughout. These code blocks are called sections in MATLAB Live Editor and can be created by clicking on the section break. So for example, I want to create a new section right after the sign function. So clicking on section break, a new section is now created. The section break allows for the selective execution of code blocks. If you only want to run the specific block, simply use the button Run Section. Then only the code in the section will be executed. So I want to execute the first section. So click on Run Section. You can see on the right-hand side only the variables angles and sin x are calculated and defined. And you can debug your code by creating breakpoints on the line numbers you wanted to pause. Just click on the line number where you want to pause the code execution. For example, on line 6, a red shadow appears. When running the code, it will halt at this point, so halt at line 6. Clicking Run. You can see on the right-hand side, a new plot is added to the output pane without the grid. And you can step through the code by clicking on Step. So first click on Run Next Line. The grid is added to the plot. And another step, the X label is added to the plot. For debugging, you can set several breakpoints. Here, I want to set another breakpoint on line 11. Let's see what will happen if I click on Continue. The title and legend are also added to the plots. And another continue will resume execution to run all the code after the breakpoint point. So now the 3D plot is also shown on the right-hand side. The outputs are shown on the right output pane, which is the right column of the interface. And there are two other modes for displaying output. One is to display output inline. So the output will be embedded after the code sections. Or you can opt to hide the code altogether, like this. Here I will choose the first section to show the outputs alongside my code. Images can be added directly within the Live Editor. So click on the figure. It brings up a toolbar with various editing options, such as adding labels and title, legends, grids, and annotations. Here I would like to add an arrow to the minimal point of the sine wave. Just click on arrow and drag to the minimal point. An arrow is added in the plot. Then I click Update Code. You can see here a new line is added to my original code. So next time you don't need to do the annotation manually. This will be realized by running the automatically generated code. When you want to save your work, you can export the current file in various formats, including the PDF and the HTML and Word for sharing purpose. Additionally, you have the option to save the current script as either a .m file or a .mlx file. Thanks for watching.